Part 3a. State in words the quantity that each symbol represents in the equation E sub h is equals to mc delta theta. State the SI unit of each quantity as well. So E sub h is heat energy, and the SI unit is the joule, or simply J. Small c, that is the specific heat capacity, and its SI unit is joules per kilogram Kelvin. Or you could also have joules per kilogram degree Celsius. And delta H, that is the change in temperature, and its SI unit is simply the Kelvin or degree Celsius. Part B, what does the symbol L in the equation E sub H equals mL represent? Well, the L in that equation represents specific latent heat. Next, part C. In an experiment to determine the specific latent heat of fusion of ice using a container with negligible heat capacity, a student obtained the following data. The initial temperature of the water was 30 degrees Celsius. The final temperature of the water plus the melted ice was 20 degrees Celsius. The initial mass of water alone was 100 grams, and the final mass of water plus melted ice was 110 grams. We're to use the specific heat capacity of water being 4.2 joules per gram per Kelvin. Part 1, we're to calculate the heat lost by the water. So we know the formula, E sub h is equal to mc delta theta. Here, we do not need to convert the mass from grams to kilograms because our specific heat capacity that we're supposed to use is in grams. So it will just remain simply as 100 grams times the specific capacity stated times the change in temperature. The change in temperature is 30 minus 20. So in other words, 10 degrees Celsius is the change in temperature, or 10 Kelvin for change in temperature. So that works out to 4,200 joules. Part 2, we're to calculate the heat gained by the melted ice. So the melted ice, the heat gain is going to be the same formula mc delta theta. The mass though is only 10 grams. Notice that the final mass of water plus melted ice was 110 grams, but the initial mass of water alone was 100 grams. So the difference is the melted ice, so that's 10 grams. And then the change in temperature will be 20 degrees because that's 20 minus 0. Because when ice melts, it melts at a temperature of 0 degrees Celsius. And so it went from 0 up to 20, which was the final temperature of both the water and the melted ice. So it's going to be 10 times 4.2 times 20, which gives you 840 joules. Part 3. Assuming the heat lost by the water is equal to the heat gained by the ice, we're to calculate the specific latent heat of fusion of ice. So, assuming the heat gained by the ice is equal to the heat lost by the water, we would then have that the energy it takes to melt the ice plus the energy it takes to raise the temperature of the melted ice is equal to the energy gained by the water, lost by the water. So ml plus mc delta theta is equals to mc delta theta. On the left hand side, the mc delta theta is the 840 joules that we just found, and on the right hand side, that mc delta theta is the 4,200 joules. The mass of the ice is 10 grams. So solving this equation for L, we would first transpose and subtract 840 from 4,200, which would give us 3,360. And then to find L, we would divide by 10 grams. So the specific latent heat of fusion of ice would be 336 joules per gram.